Today we're going to be talking about solving equations. And what I want you guys to do is before you do anything, I want you to go to the book and I want you to define these three terms: open sentence, equation, and solution in your notes, and give me an example. Okay, our first example. Write an algebraic expression to represent the verbal expression, the square of a number decreased by the product of 5 and a number. So hopefully you realized that an algebraic expression involves variables and numbers. So we have to first describe our variable and define our variable. So we're going to say n is a number. So the square of a number squared, decreased, so that's subtracting, by the product, so multiplication of 5 and the number. So that's our algebraic expression. Expressions don't have equal signs. Equations have equal signs. Write a verbal sentence to represent 7y minus 2 equals 19. Okay, so we have, first thing we have there is we have 7 times y. So kind of like the last example, we have the product of 7 and a number is decreased by 2 is equal to 19. So let's break that down. The product of 7 and a number is this first term here, 7 times y, is decreased minus 2, and then we have equal to is equal to what our equation was equal to. This is going to come in handy when we get to different word problems. So it's important that you guys are able to write both a sentence going back and forth, from going from an equation to a sentence and a sentence to an equation. Now solving equations. First we have to distribute the 3 to everybody. So when I distribute the 3, we get 6x plus 15 plus 7x is equal to 9 plus 3x. Now combine all your variables, the 6x and the 7x, on one side. Now subtract the 3x over. The reason I don't subtract the 13 over is it's going to make my variable negative. So if I subtract the 3x over, we get 10x. If I subtract the 15 over, we get a negative 9. I'm sorry, we get a negative 6. Then I divide by 10. And we are always going to reduce our fractions, so that reduces to negative 3/5. And we can always check this answer for x. It might be a little hard because of the fraction, but it's always a possibility for us. Our next example. Now first I'm going to give you guys the most common mistake. The most common mistake is students want to multiply by 3. And when they multiply by 3, they get what they forget to do is they forget to distribute this 3 to the 2x. So instead of doing that, what I'm going to have you guys do, so instead of doing that, if you have a function who has a fraction, so we have a fraction here minus a 2x. So if you have a fraction with a term being added or subtracted to it, add that term over to the other side. Now what we can do is we can multiply by 3 on both sides. That cancels out that 3. So we're just left with what was in the numerator, and then distribute the 3 to everybody. Now distribute this negative 2 through. And combine your like terms. So if I add the 2x over, we get 8x. And if I subtract the 24 over, we get negative 10. So x is going to equal negative 10 over 8. And I always want you guys to give your answers as improper fractions, but always reduce them, so it's negative 5 over 4. Okay, this next example we need to get rid of. The easiest way to do this is to get rid of what's in the denominator. So figure out between 4, 2, and 3, what's the smallest number that all 3 of those numbers go into? The smallest number is 12. So if we multiply each one of our terms by 12, we're going to cancel out what's in the denominator. 12 and 4 cancels to be 3. So our first term there ends up being 3x. 12 and 1/2 cancels to be a 6. 12 and 3/4, 4 and 12 cancel so that I have a 3. So I really have a 9x plus 8. So if you multiply by essentially the common denominator, or the least common multiple of all those, you get rid of the denominators. Just make sure you're multiplying every single term by that denominator. Okay, so now what we're going to do, I'm going to subtract the 3x over. I'm going to subtract the 8 over. I'm going to divide by 6. And then, as always, we reduce. Okay, when we're solving equations, sometimes we're going to have special types of equations where either we're going to get all solutions. So if you get something like 5 equals 5, that's always true, so it's all solutions. Or if you get something where two things don't equal each other, like 3 equals 4, that's technically no solutions. So on the left side, I'm first going to combine my like terms. And then if I add x to both sides, we get a statement that's never true. So that's why no solutions. On part B, I'm going to distribute the 2 on the left. On the right, I'm going to combine my like terms. So if I were to add 12 to both sides, the 12s would cancel. If I were to subtract 2x to both sides, those would cancel. So essentially, I would get 0 equals 0. Well, that's always true. So that's all solutions, or I like to say a lot of times, infinite solutions. Okay, the formula for surface area of a cone is given to us, where L is the slant height and R is the radius. Solve this formula for L, our slant height. So that's our variable. And the reason we do this is, in your science classes, the science teachers expect you to be able to do this a lot. So think of L as your variable and everything else is numbers. So to isolate that L, since something's being added to it, I have to subtract I'm going to need to subtract this term to both sides. Doing the opposite operation that's happening to it. Now, since pi and r are being multiplied to L, I need to divide by those so that I finally get my slant height L equal to s minus pi r squared over pi r. Okay, if 4g plus 5 equals 4/9, what is the value of 4g minus 2? Now, I bet you a lot of you guys are going to want to do this. You're going to want to solve this equation for g. So let's see what happens when we do that. I subtract 5 from both sides. So I have 4g equals 4/9 minus 5. Well, 5 in terms of ninths is equal to 45 over 9. So then I subtract, and then I divide by 4, or really multiply by 1/4. I'm going to be honest with you guys. This looks like a really scary answer, and even me as a math teacher, I don't want to plug that in for G. Let's look at what we're given. I have a philosophy that I stole from somebody, that I borrow from somebody that I used to work with, and it's work smarter not harder. Okay? So let's look at this original question again. I have 4g plus 5 is equal to 4/9. Notice how I have 4g plus 5. I need to get it to 4g minus 2. So how could I change 4g minus 5 into 4g minus 2? Well, if I took this left side and I subtracted 7, I have 5 minus 7, that's going to get me 2. But remember, it's an equation. You need to stay equal. So what I do to one side, I have to do to the other. So now when I simplify this left side, I have 4g minus 2. All I now have to deal with is this crazy fraction. So I have 4/9 minus 63 over 9. So what's the value of 4g minus 2? Negative 59 over 9. Okay. You could have done it this other way and then plugged in this negative 41 over 36 in for g, because that's originally what I was thinking we would do. But with this crazy fraction, we're most likely going to make a mistake. And we want to try and not make as many mistakes. So that's why I did it this other way, where we work smarter, not harder. Remember, we want to conserve our energy. Okay, here are your lesson questions. Please make sure that you fill in the lesson summary, give me a question that you had from the lesson, and then you submit the answers to these 3 lesson questions for me on time.